So hello guys, welcome to today's new live stream. Today we are gonna review Leetcode's biweekly contest 149. I hope you all are doing well. So guys, how many of you gave today's contest? Anyone who gave today's contest, guys? Compared to last week's weekly, this contest was pretty much easy. How did you guys feel about today's contest? I think we can go to the first question. The first question of today. Find valid pair of adjacent digits in string. So the first question of today, find valid pair of adjacent digits in string. You are given a string S consisting only of digits. A valid pair is defined as two adjacent digits in S such that there is a condition for valid pair. First digit should not be equal to second digit, and also each digit that appears in S is exactly as many times as its numerical value. For example, if 5 appears in a number, then it should appear 5 times. And also the it should not be 55. The number can't be 55. It can be 56, and the number can be something like 56, 56, 56, 56, 566. This can be the number if the number is made of 5 and 6. So what should we return? Return the first valid pair. We have to return only the first valid pair found in the string when traversing from left to right. If no valid pair exists, we have to return an empty string. So we have to traverse from left to right. We have to traverse from left to right. If no valid pair exists, return an empty string. What is the example given? We'll see the example. The first example. Input S is equal to 2523533. So output 2 and 3. Digit 2 appears 2 times and digit 3 appears 3 times. Each digit in the pair 23 appears in S exactly as many times as its numerical value, hence the output is 23. So they have given that in the given number 2523533, 2 appears twice and 3 appears thrice. So this is a valid pair. Going on to the third one, we'll go to the third example. Second one is also pretty similar, 2 to 1. 2 appears twice and 1 appears once, hence the output is 21. So we'll go to the third example, 2 2. 2 2 can't be 1 because the numbers are repeating. If the numbers repeat means it's not a valid pair. So we have to return output as an empty string. Empty string is given as the output. What are the constraints given? Constraints are length of S is greater than or equal to 2 and lesser than or equal to 100. And S consists of digits from 1 to 9. There's no 0 here. So we'll go on to solve this question. There's no need of hint for this question. Anyone in the chat, what is the way we can solve this question? What is the intuition for this question? Anyone in the chat, guys? What is the approach or what is the intuition? So chat. The intuition for this question is we have to find the adjacent pairs of digits in the string that satisfies the given condition. What is the given condition? What is the given condition? The first condition is so the first given condition is two digits different, two different digits Two different digits. Two different digits. And what is the second condition? Second condition is exact repetitions. Exact repetition. We'll write it as repetition. Exact repeat. These are the two given conditions. So these are the two given conditions. What is the approach we are gonna use to solve this question? Very simple one. First, first one. First one. What is the first thing we are gonna do? Count frequencies. Count frequencies. Count the frequencies. Next, first we have to use counter from collections. We'll use Python's inbuilt collections library to store the frequency of each digit in S. This is the first step. And what is the second step? The second step is I'll just collapse this. So the second step is iterate through string. Iterate through the string. Iterate through the given string. For this, what we'll do? Traverse the string from left to right. For each adjacent pair S of I minus 1, S of I, we'll check this condition. If digits are different, S of I not equal to S of I minus 1, and the count of S minus 1 should match the numeric value of S of I is equal to S of I count of S of I, and also the count of S minus 1 should match its numerical value S of I minus 1 is equal to count of S of I minus 1. If all these conditions are met, we'll return valid pair as string. If not, the final case. What is the final case? Return empty string. Empty string. Empty string. Return the empty string. So these are the given conditions. So this is how we are gonna solve this question. We'll go to the code. Okay. Here is the very simple code of 5 lines. Given class, it's already given class solution, and also this is given the function is defined already, find valid pair, and the next step counter. We all know why we are adding a counter, to count the number of times it's occurring. I just put a hashtag frequencies for I in range 1 comma length s if adjacent are different. If a adjacent are if adjacent are different. Now, the second one, again, same case. Why we are using if? This is for if S is exactly same as numeric values. S is same as numeric values. If yes, return valid pairs, return valid pairs. If not, empty string. Return empty string. So we are gonna run this code and it is accepted here for the given test cases. Now we'll see for the hidden test cases, we'll submit the code and the code works perfectly for all the test cases. Now, anyone in the chat, what is the time complexity of this question? What is the time complexity of this code? Anyone in the chat, what is the time complexity of this question? Chat, what is the time complexity and the space complexity for this? Anyone? Yeah, May coach, you are right. The time complexity for this is gonna be O of n. Can you say why it's gonna be O of n, May coach? Yeah, right, it's O of n. And what about the space complexity? What about the space complexity, May coach? Or anyone in the chat? Yeah, you are right, May coach. It's because the frequency count array is also running for O of is for n times, and the traversal is also for n times. So the total time complexity will be O of n. What about space complexity? Yeah, you are correct, May coach again. The, s- the space complexity is gonna be O of 1 because we are using a fixed size dictionary here and a few variables which are of O of 1 itself. So the overall time complexity for this is gonna be O of 1. So guys, any doubt in this first question? Any doubt, chat in the first question? I hope it is clear. We'll go to the second question of today's contest. Reschedule meetings for maximum free time 1. So this is our next question. We'll see. What is this question? Okay, you are given with an array. Sorry, you are given with an integer event time denoting the duration of an event where the event occurs from time t0 to time is equal to event time. You are given with two integer arrays, start time and end time, each of length n. These represent the start and end time of n overlapping meetings, where the ith meeting occurs during the same time, start time I, start time of I, comma, end time of I. You can reschedule at most k meetings by moving the start time while maintaining the same duration to maximize the longest continuous period of free time during the event. The relative order of all the meetings should stay the same, and they should remain non-overlapping. So there can't be two meetings at the same time, and the order should be same. So we'll consider A, B, C, D are four meetings. If A, B, C, D in we can't change the order. We can't make it C, B, C, B, A, and D. It should be A, B, C, D itself, and also it should not overlap. A can't overlap with B. Now we have to return the maximum amount of free times possible after rearranging these meetings. Note, the meetings cannot be rescheduled outside the event time. So it can't be rescheduled outside the event time. We'll go for the example. Event time is equal to 5, k is equal to 1. So event time they have given us event time. This t is given as 5. And then k is the maximum number of times it can be rescheduled. So k is given as 1. So, and the start time is given 1 comma 3 and end time is given 2 comma 5. So, what is the maximum time? So that you will get a highest break here. So what is the maximum break time you will get it? So we'll reschedule this meeting now from at 1 to 2 to 2 to 3. We'll move this from 1 to 2 to 2 to 3. So that there is no meetings from 0 to 2 and we are getting a break time of 2 hours here. We'll go for the second example. The second example, input time, event time 10, start time 0 comma 2 comma 9, end time 1 comma 4 comma 10. So the first event is from 0 to 1, second event is from 2 to 4 and the third event is from 9 to 10. So and the k value is 1, only one this thing can be changed. So what are we gonna do? Here there is we can't change the order. So 0 to 1 should be the first one. So instead of 2 to 4, we'll change the second meeting to 1 to 4. There's no overlapping. By 1, the first meeting is ending. From 1 to 3, the second meeting is gonna end. So there will be a free time from 3 to 9 of 6 units. 6 units of free time is there. We'll see the third one. Event time is 5 and k is 2. Start time is 0, 1, 2, 3, 4. End time is 1, 2, 3, 4, 5. There's no free time left here. So we have to return the output as 0. What are the given constraints for this? Event time is lesser than 10 power 9 and greater than 1. Start time length is equal to end time length is equal to n. N is smaller than 10 power 5 and greater than 2. N and k is smaller than or equal to n and greater than 1 or equal to 1. The start time is greater than 0. End time I is greater than start time. And the end time is equal to or it's greater than or equal to the event time. Sorry, the end time I is smaller than or equal to the event time. And the end time I is equal to start time I plus 1. So for example, at least this means that every event should be of at least 1 units of time. So where I lies in the range 0 to n minus 2. So the range of I is 0 to n minus 2. So now we'll see the approach to solve this question. We'll just close all this. So yeah, we'll go to the next question. So for this question, what is the approach we can use to solve this question? Sorry, what is the intuition first? We have to maximize free time, that's all. Shit, sorry guys. We have to maximize free time. We have to maximize the free time. This is our only intuition. We have to shift for this. We have to shift the meetings. We have to shift the meetings for this. And the conditions. First one, no overlapping. No overlap. Second one, order can't change. Order can't change. The order can't change, and there should be no overlapping. Now, anyone in the chat, what is the approach we can use to solve this question? It's a very commonly used approach which we are gonna use to solve this question. Anyone in the chats, just tell the name of the approach which we can use to solve this question. Anyone in the chat, what is the approach which we are gonna use to solve this question? For this question, we are gonna use sliding window approach, which is the most commonly used approach here for these kinds of questions. So what are we gonna do here? First step, approach. What we'll do? Okay, sorry. So the first thing we are gonna do is identify free time. Sorry. Identify free time gaps. Identify free time gaps. Identify free time gaps. So for this, what are we gonna do? Compute the gaps before the start of meeting, before the first meeting. Start time 0 if not 0, if it's not 0, and after the last meeting. Event time minus end time minus 1 if it is not 0. So this is our first step. We have to identify the free time gaps. For that, we have to compute gaps before the first meeting and compute the gaps. The second step is computing the gaps between consecutive meetings. For that, what we are going to do is start time I plus 1 minus end time I minus 1. What we are going to do for that is start time I minus minus 1. Start time I minus 1. Sorry. Start time I plus 1 minus end time I end time I. So this is what we are gonna do here. Going on to the second one, the second step in the approach. What is gonna be the second step in the approach? The most important step, sliding window. Sliding window to find max free time. Sliding window to find the maximum free time. Anyone in the chat, how are we gonna do this? Yeah, may coach, you are right, it's sliding window only. How are we gonna use sliding window in this question? Anyone in the chat? For this, the first step we are gonna use is in the sliding window, number of modifications. What is number of modifications given here? It's given as k. Will since if we merge k gaps, it will create larger free period. We'll apply sliding window of size. Anyone in the chat? What can be the sliding window of this one? What is the size of sliding window we can use for this? So we are gonna apply sliding window of size k plus 1. This is the size of the this is the size of the sliding window which we are gonna use, and we'll start by computing the first first k plus 1 gaps, and then finally we'll slide the window across the array, across the array, dynamic updation of sum, dynamic update of sum, dynamic updating of sum, and tracking track the maximum observed value. Tracks track max observed value. So this is the approach which we are gonna use this. Now, so there's a doubt in the chat. Why k plus 1? So, anyone in the chat, can you answer why we are using k plus 1 for the sliding window size? Simple thing. Because K meetings allows merging of K plus 1 gaps. So K meetings when shifted are gonna use K plus 1 gaps. So this is the reason we are using. See, for example, each of the shift is gonna move for a meeting and effectively merging two adjacent gaps. And then with K shifts, we can merge K plus 1, K plus 1 gaps into a single block. So the maximum possible free time will use the sliding window of size K plus 1. So here we are ensuring that largest continuous free period is achievable by rescheduling. So this is the logic. If you need an example, we'll just go for an example for you. Consider we have I'll just write gaps 2, 3, 4, sorry, wait, 2, 3, array, 1, 4, 2. Consider this is the gaps we have, and we'll consider that k value is 2. K value is 2, so we can reschedule it twice. Now, if there is 2 shifts available, the number of merges is 3. Number of merges that can be made is 3. So, we are gonna use k plus 1 instead of k plus 1 and not k. If you use k, the number of merges count will be lost. So, we are gonna use k plus 1 and not k. So, I hope it is clear. So, make codes, I hope it's clear. Now, we'll go to the code and here is the code for this. Class solution, which is given already, the function name, which is given already. Now, the first one, this is all variables, initializing the variables. The first one is meeting length, comma, gaps, list. Now, if start time is not equal to 0, we have to bring back the start time to 0. We have to bring back the start time to 0 if it is not 0. Now, the next one, calculating the gaps. To calculate the gaps between consecutive meets. And the second one, if end time minus 1 not equal to event time. What is this? If end and event time end is not at event time. So then we are gonna append the value as event time minus end time of minus 1. and will then here comes our sliding window. Here comes our sliding window, and next here we are gonna use a slide. This is all completely sliding window now. And finally, we are gonna return our max value. And this is our final max value. This is our free time, max free time. This is our max free time. Now we are gonna run this code. So this runs perfectly in the given test cases. Now we'll submit it and see if it works for the hidden test cases also. Guys, okay, this is after submission, this works. Any doubts in this question? Anyone, what is gonna be the time complexity for this question? Now, chat, what is the time complexity for this question and how? And what is the space complexity also for this question? Anyone in the chat, what is gonna be its time complexity and space complexity? May codes again, you know what is the space complexity and time complexity for this? Guys, what is the time complexity and space complexity for this question? A very simple one. So the time complexity of this is gonna be O of n. Reason is simple, like constructing the array will take n space, n time, and then sliding window will be O of 1, and it will go for n times, leading to the space time complexity of O of n. So this is the time complexity. And what is the space complexity? What is the space complexity? Yeah, Miko, it's O of n. You're correct. The space complexity is also gonna be O of n. The reason is array stores the number of gaps, right? So the maximum number of gaps can be n, which leads to the time complexity of O of n. So guys, I hope you are all clear with this question. Anyone has any doubts in the second question? Any doubts in sliding window or anywhere in the code? I guess the code is visible. Anywhere in the code or anywhere in the question or time complexity, space complexity, anywhere in this question, any doubts, guys? So shall we move to the next question then? Okay, so we'll move to the next question. What is the next question? The same question again with a little bit of changes. Now, we'll go to the next question. Reschedule meeting for maximum free time 2. We are given with integer event time denoting the duration of an event. We are also given with two integer arrays, start time and end time, each of length n. These represent the start and end time of n overlapping meetings that occur, n non-overlapping meetings that occur during the time t0 and time event time, where ith meeting occurs during the same time. During the time start time I to end time I, you can reschedule at most one meeting by moving its start time, maintaining the same duration, such that the meeting remains non-overlapping to maximize the longest continuous period of free time during the event. Return the maximum amount of free time possible by rearranging the meetings. Note, it can't be rescheduled at a time outside event and it should not be overlapping each other. Now, another note. In this version, it is valid for relative ordering of meetings to change after rescheduling of one meeting. So, relative ordering can change here. So now we'll see. Event time is 5. The change from last question and this question, anyone in the chat, what is the change between last question and this question? Last question had K, and this question, it is 1 here. It was given somewhere. At most one meeting. So we'll see the example. Event time 5, start time 1, comma 3, end time 2, comma 5. So what is the maximum time we can do it? Now, end time is 5. If we reschedule the meeting from 1 to 2 to 2 to 3, then there are gonna be no meetings from 0 to 2. So the output is gonna be 2. The next question, for the next question, event time 10, start time 079, end time 1810, output is 7. So if we reach here, there's a condition given. It's valid to change the relative orders. So this 1 comma 0 comma 1, we are gonna shift it to 8 comma 9, so that we'll get 7 hours of free time, like 7 units of free time from 0 to 7, and this is gonna give us the output as 7. We'll see the other example. It is simple, and we'll go for the final example. So the final example, example 4, event time 5, start time 0, 1, 2, 3, 4, end time 1, 2, 3, 4, 5. 0 is the output because we cannot reschedule any meetings here because all are occupied by meeting, and there can't be any overlappings. Hence, the number of what is the number of free time is equal to 0. What are the constraints for this question? Event time is lesser than 10 power 9 and greater than 1. Start time is equal to a end time length is equal to n. And the value of n is greater than or equal to 2 and lesser than 10 power 5. So the start time is equal to or greater than 0 and smaller than end time, and the end time is greater than or smaller than or equal to the event time. And the end time is smaller than or equal to start time of I plus 1, where I lies in the range 0 to n minus 2. The range of I is 0 to n minus 2. So, what is the intuition to solve this question? Anyone in the chat? What is the intuition to solve this question? We'll see. We'll go to our note screen. So here we are. What is the intuition, guys? Again, same max free time. So it does no change here. It's just maxing the free time again. What is the approach we are gonna use? Anyone in the chat? What is the approach we are gonna use? What is the approach we are gonna use to solve this? So guys, what is the approach we are gonna use to solve this question here? First one, calc calculate free time gaps. Calculate free time gaps. Second one, the second step, pre-compute, pre-compute, prefix and suffix maximums. And what is gonna be our third step? This is the first step. So what is the third step, chat? The third step is max free time calculate. Finding the max free time. Finding the max free time. And the final step, check if reschedule is possible. Check if rescheduling is possible. Now, what are we gonna do first? Calculate the free time gaps. For this, exactly like the previous question, include the time before first meeting and after the last meeting. For the second step, these arrays will make these two arrays prefix and suffix. These arrays will help us efficiently to check if rescheduling a meeting can merge two gaps to create a larger free time. And also, the third step, find the maximum free time. How are we going to do this? There will be two cases. Consider two cases. First case, here in max free time finding, max free time finding. max free time finding, we are gonna have two cases. The first one, existing maximum gap, existing max gap, existing max gap, and what is the second step? The second step is merging two adjacent gaps by shifting one meeting. So this is what is the steps which we are going to use. And finally, check if meeting can be rescheduled. If moving a meeting allows, so if we move a meeting, if it's gonna allow the merging of two adjacent gaps, merging. So we are gonna check if it's gonna do that. Now we'll go to the question. We'll see the code. Here is the code. Now, what is the explanation for this? Okay, step one, like we know why we are using this for I in range n. Anyone in the chat? Why? This is all pre-computing things. Gap before start time. This is prefix. What is prefix? Anyone in the chat? What is prefix? Max gaps from, and what is suffix? Max gaps from. Which is from which side? Which is from right and which is from left? Anyone in the chat? Which of this is gonna be suffix is gonna be from left or right? And what about prefix? Prefix is gonna be from right or left. So the prefix is gonna be max gaps from left, and suffix is gonna be max gaps from right. And now, what is this suffix equal to suffix of I minus 1? This is, everyone knows, reversing array. To reverse an array in Python, we are gonna use two colons and minus 1. So next, what is this? For I in range, the final for loop. This is, what is this? Block size equal to n time I minus start time I. This is duration of current meeting. Duration of current meeting. And left gap before meeting. And right gap is gap after meeting. So, and finally, the if condition, sorry, this max gap, this is merge thing. If merging left and right is gonna help us to uh, increase the maximum number of free time we have. This is merging. And finally, this is what? is our max gap solution. Max free time. Max free time. So we are gonna run this code, and now this is accepted in the given test cases. Now we are gonna submit this and check if it works for the hidden test cases. And yeah, it works perfectly for the hidden test cases as well. It's accepted. So what is gonna be the space complexity and time complexity for this? It's exactly the same as the last question. O of n, O of n, array taking n space and sliding window will take, sorry, array is taking n steps. That's the reason why this is gonna be O of n, both the space complexity as well as the time complexity. So guys, any doubts in this question to anyone in the chat? If everyone are clear with this question, we are gonna move to our last and the final question, which is a bit hard as well as a lengthy question. Anyone has any doubts, chat? So okay, we'll move to the final question of today. Our final question is gonna be minimum cost good caption. So what is this question? You are given with a string caption of length n. A good caption is a string where every character appears in group of at least three consecutive occurrences. For example, AAA, BBB, and AAA, CCC are good captions. AABB and CCDD are not good captions. You can perform any number of you can perform the following operations any number of the time. What is the operation given? Choose an index I where I is smaller than n and greater than or equal to 0. Change the character at index to I to either alphabet, the character immediately before it in alphabet if caption I not equal to A, and immediately after it if the caption I is not equal to Z. You are given the caption it into a good caption using the minimum number of operation and return it. You have to return the minimum number of operations. If there are multiple possible good captions, then we have to return the lexicographically smallest amongst them. So lexicographically, in the sense, in the dictionary order. If there are multiple good captions, we are going to return the one which comes first in the dictionary. So if A and D both are making good captions, we are return the A one because A is going to appear first. String A is the lexicographically smaller string than string B. If in the first position where A and B differ, string A has a letter that appears earlier in the alphabet than the corresponding letter in B. If the first minimum of A dot length, comma B dot length characters do not differ, then the shortest string is the lexicographically smaller one. So now what are we gonna do? We're gonna see the first example. Caption given here is CD. So now output is 4C, CCCC. Explanation. What we can do here is two things can be done. Caption 0 and caption 2 can be changed to D, and caption 1 and 3 can be changed to previous character, which is C. So these two are there. We'll go to note for a second now. Here we are. So C, 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 D, 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 and D. Two possible ways are there for this. Now, since C is gonna appear first in the dictionary, we are gonna give the output as C, cancelling D. Lexicographical order, C is gonna appear first. So we are gonna return C as the output. Now, the next question, B and C. Caption is BC, so it's not possible at all because there should be three minimum operations. It's impossible to convert it. Now we'll look at the constraints. What are the constraints? Length of the caption is greater than 1 and lesser than 5 into 10 power 4. And the caption consists of only lowercase English alphabets. So there is no need to convert L case and U case. It's directly given that there are only lowercase English alphabets. Now, we are going to solve this question. What is going to be our approach? We'll go to our writing screen again. What is going to be the approach to solve? Sorry, what is going to be the intuition to solve this first? Intuition. Okay. Good caption. For this, what we are going to do is first point, each segment of length is equal to 3 or more. This is the first thing. And what is going to be the second thing? Each character changed to its adjacent alphabet characters. It means that we need to find cheapest way. We have to find the cheapest way. And what is the third one? We have to select the lexicographically. Lexicographically smallest. Lexicographically smallest caption. So these are the three main things in our intuition. Now, what are we gonna use for this question? Anyone? What is one thing which is very important for this question? May coach or anyone else in the chat. We're gonna use a very important concept in data structures and algorithms here. So guys, here finally we are gonna use uh, What are we gonna use, guys? Anyone in the chat? So we are gonna use DP or dynamic programming array. DP arrays. So now we'll see how we are gonna use it. Now, our approach. Approach. The first step. Okay, wait. Approach. Our first step. What is our first step? Pre-compute. Pre-compute cost. Pre-compute the cost by transforming any given substring any given substring into uniform segment. This is our first step, pre-computing the cost by transforming any substring into a uniform segment. So how we are gonna do this? We are gonna make a two-dimensional cost table, which is cost C and I, which represents the cumulative cost to convert the first I characters of text into the character A plus C. This helps in efficiency. This helps in increasing the efficiency to compute the cost of converting any substring into a single character. So this is the first step. Now, what is the second step we are going to use? Second step. Here comes our main. This is the main step. We are going to use DP to determine minimum cost transformation. We'll use DP to find the minimum cost transformation. How we are going to do this? We'll let DP of I may store the minimum cost of transformation of text I colon into a good caption along with lexicographically smallest transformation. And then what we are gonna do? Then we are gonna fill this DP of I by iterating it over the possible segments. For example, 2 or 3 or 4. And then we'll compute the cost for each. So when after we compute the cost for each, cost will be computed. After this, we'll choose the best one. Best is the cheapest one. Best here directly means cheapest. So after this is the second step and the final step in the approach. Third step, it's gonna be constructing result string. constructing a result string. How we are gonna do this? We'll use the DP array. We'll use the DP array, and then we'll reconstruct, we'll reconstruct the transform string, sorry. We'll reconstruct the transforms string by following by following stored segment. So this is the approach we are gonna use for this. Now what we are gonna do? Now we are gonna shift our screen to the code. Here is our code. It's pretty lengthy, but no issues. We'll just go through it. So the first one is just say the important topic. Class solution. We have to create a function. First one, minimum cost of good caption. Second one, calculating the cost. Next one is notes for checking the notes. To compare, here CMP is nothing but compare. We are comparing the lexicographical representation. So, for example, if A and B are there, we are gonna give A in the output. So, the first thing, cost. Where is this thing? And here it is. The most important case, less than 3. 3 means never possible. Good caption is never possible at all. Now what next? Next thing what we have to do is, this is the function to calculate the cost. Calculate the cost of converting substring into a single character. So after this, we'll create one more function to compare. I just write it compare lexicographically. It's to compare the lexicographical representation. Now we'll move on. Here is the most important thing, the DP array. DP array to store minimum cost and lexicographically smallest. The first one is base case. Base case means no cost for an empty string. Base case, which is no cost for an empty string. So the next one, iterating backwards. Iterating backwards. This is if-else conditions we are using here. Finally, we are gonna construct the result. Construct the result from DP table. This DP best, it will store the best transformation. This is for computing the cost. Compute cost for converting it to single alphabet. And this if condition here, if else elif conditions. This is to choose minimum cheapest. Cheapest is equal to best. We'll simply do it this way. And now finally, we are gonna join the result we are gonna return the result as string. Now we are gonna run this code and it runs in the given test cases. Now we are gonna submit this to check if it runs for the hidden test cases. And it runs perfectly for the given hidden test cases also. So anyone in the chat, what will be the time complexity of this? What will be the space complexity and time complexity of the given question or the given code? So guys, time complexity. Cost table pre-compute. Pre-computing, what it is gonna take? What is the number of characters? It's 26. Pre-computing is gonna take 26 into n. O of 26 into n, which is nothing but O of m. Now, second one, dp. dp is also gonna take O of n since the indices value is O of n, simply. And results construction. Result construct. It's also gonna take O of n. So the overall time complexity for this question, the overall time complexity is gonna be O of n. What about the space complexity? Anyone in the chat, what is gonna be its space complexity? Similarly, what is gonna be its space complexity? Space complexity. First one, cost table. for cost table, size 26 into n plus 1, which will be nearly equal to O of n. Now we'll move on to the next one. The second one is DP arrays, and the size of DP arrays is O of n. It's known for us. And the third one, result storage. Result. Result is also gonna take O of n. So this leads to a final space complexity O of n, and the time complexity is also O of n. So with this, we have completed explaining and discussing about all the four questions. Now, if anyone has any doubts in all of these questions, any of these questions, I'm gonna explain it again to them. Check any doubts in any of the four questions. So, any doubts in the chat? Thank you for everyone who joined to today's stream, guys. I guess we can end the stream. Anyone watching this, please like, share, and subscribe to the channel. With this, we are gonna end today's live stream. We'll be back tomorrow morning with Leetcode 440's next contest, weekly contests reviews by tomorrow morning 9:45 a.m. in IST. Until then, bye bye everyone. Thanks for tuning in. Good night, guys.